Thanks, Ravi. That was an excellent introduction to RMR. Our last speaker for this session is going to be Leigh Metcalf from CERT at CMU. She'll be talking about both the Silk tool suite, which are an excellent way of looking at traffic data, as well as how potentially they can be adapted for looking at routing information.
So hi, thanks. I'm Leigh Metcalf. I actually am a researcher these days, but at one point I was operational. I actually do not miss being paged at 3 in the morning, and so I'm very happy to be a research person now. So by research, I mean I have as much data as I can get my hands on. CERT has a mirror for both RIPE routing data and RouteViews routing data. It's available at routeviews-mirror.cert.org. And I hope I have that right. So anyway, I have all this data. And so one day, my coworker said, how do I find things in it? And that's how this came about. First of all, I'd like to say I did not name this. Okay, that was not me. That was Rachel Karch, if Rachel's in the room. Hi, Rachel, in the back. Yeah, I didn't name this, nor did I came up with the acronym. That was another coworker. I just write the software. So then we have lots of legalese everyone can pretend they saw. So the statement of the problem was, well, Timur came into my office one day and said, I have these CIDR blocks. I want to know all routing announcements that could have affected them. And by the way, I need it soon. Can you do it fast? So if he wanted just matches, then that's a BGP dump piped into a grep and I'm done. But he wanted the subnets and the supernets that could have affected, I think he had a /24 at the time. And I said, okay, let's see if I can do this. Luckily, I work with a lot of very smart software engineers who have written this tool suite called Silk. And I combined Silk with RIPE's BGP dump, and I made BGPuma. So first, let's talk a little bit about Silk. Silk, as mentioned yesterday. Silk is really designed for security, but doesn't have to be just used for security. It is incredibly fast. It is designed with the Unix file system in mind. So when it stores files, it wants to use your directories. And it's available at the URL at Tools. It supports collecting, storage, analysis, and it works with IPFix. And there's also a Python plugin, PySilk. I promised I would mention it, so there you go. And it has lots of documentation. And did I mention it's really fast? I had this 39 gig PCAP file, and I just wanted to know how many flows were in that PCAP. So I started a TCP dump, because when I see PCAP, I think TCP dump, and let's see how long it takes. Hours and hours and hours later, I finally got a number. Well, the guys I worked with said, why didn't you do Silk? So I used Silk, and Silk has two tools. One of them's called, I'm not even going to try to do it, it's RWP to YAF to Silk, which takes the PCAP files, turns it into Silk files, and then I can use the Silk commands to actually run it. It did it in 3 minutes. So I was hours and hours, and that's even with using all the TCP dump commands that say, don't look things up, just give me the raw stuff, versus 3 minutes. I went, okay, I'm sold, you guys are great. Beyond its basic abilities for storing network data, Silk has IP sets, and these are optimized actually for CIDR blocks, but being me, I had to test and see exactly how fast and how strong they are, because, well, I'm a researcher. If someone tells me IPv6 is everywhere, well, then I go write a blog post, which I did about 2 years ago for CERT, that says, well, yeah, it is trending upwards, but it's not everywhere. So I took a bunch of sets I created. One, I took every odd IP address in the internet, and yes, this is a very strange thing to be taking. And I took every even IP address, which I'm sure no one actually has ever used ever. If you have, please let me know. I'd like to know why. And I did that because I looked at how silk worked with sets, and I said, this is the absolute worst case scenario for silk. This is going to be pathetically slow. Not really. It's still pretty fast, and it works in seconds to compare all of those guys. But it's really designed for cider blocks. So that's what I use for BGPuma. And the silks are available by themselves. You don't have to install all of silk if you just want to use the sets. I actually have a CERT blog post out, which it's how to save MD5s as IPv6 sets, because they're both basically the same size. One's got colons, one doesn't. And you can save and store and search MD5s very fast with it. Now, on the other hand, how I use this is Silk has libsilk, which is a library that was designed for it, and it allows you access to all of the Silk functionality. So if you download Silk and you say, I don't like the way these tools work, but I kind of like the way it does some of the things, well, you can just write your own version. And my coworkers laughed at me when I put this slide in here, but I've worked with an awful lot of libraries that have an awful lot of horribly documented code. This code is amazingly documented. The lead programmer finds it offensive that everyone else doesn't do it the same way he does. Yeah, it's a little funny, but he documents everything. It's not just the case of the top of the file, you can read this and say, this is what this is in this file. He also documents how the things work within there. So if you really want to know how Silk IP sets work, you can download the code, look at it, and go, oh, that's how Mark made IP sets work. So BGPdump is a library written by and supported by RIPE. It includes a library and a program for managing the BGP update files, MRTG, Zebra updates. And so BGPuma is basically the child of the two of them. I took libsilk, I took BGPump, I put a little C++ in the middle, and I got BGPuma. And if you want to ask me why I did C++, I'll tell you, I'm lazy. That's my former sysadmin years talking. So how does BGPuma work? Well, you give it a list of update files, you give it a list of ciderblocks or prefixes or whatever you want to call them, and you run it just like that. You say BGPuma-files, file containing the list of all the files, and then you have a list of all the prefixes, and it prints out an output. For example, I occasionally look and see who's announcing private IP space, or non-routable, whatever you want to call it, and that's what I get out. And it's basically the same output as BGPdump. It's just filtered down to the net blocks that I'm interested in. So on the first line, it found a /32 in 10. And the second one, it found a /24. And also, because I have all the data, it also understands the directory structure for both route and RIPE views. Excuse me, RIPE and route views. Because, like I said, I have all the data. So I'm lazy and didn't want to spend all my time making lists of files to go search through, so I made it understand the directory structure. So if you have some way of remote mounting these in whatever fashion, I personally use SSHFS because, well, I have SSH access. You can run BGPuma on days, and it will be happy to do so. It understands what each of those are supposed to look like. And so there's the output for an extended run. And the output is explained. It's actually in the documentation exactly what it looks like. The timestamp the route announcement was seen, an announcement or withdrawal, the source IP, the source ASN, the destination IP and the destination ASN, the CIDR block, and if an announcement, the actual path. So this comes up occasionally, well, more than occasionally. Lee, they want to know why this happened. Go check the routing for me. And so I go and run and see that, okay, for this DOD that no one's supposed to be announcing, yeah, someone did. And they announced the /24 in it. But it's a typo because you can just look at it and go, oh, yeah, that's, one off from theirs. They're missing a 1. It will also look for autonomous systems, so that if you want to know any announcements that contain any of your autonomous systems, it will do those. And it will do both of them at the same time, as in you'll say this autonomous system and this prefix, or you can give the infamous OR flag and it'll do OR. And there's some other options. Basically, if you don't want your output to go to standard out, it will dump it into a file. And there's help file. There's a help. I even gave help and verbose. Now, speed, this is the part which really makes BGPuma happy, is that I picked a day, random day, and said, give me the largest file that showed up on this random day, and it was a 40 meg file. And so BGP dump, on average, took 39 seconds to go through it. BGPuma, 53.4 seconds. Well, excuse me, 53.8 seconds, so about 14 seconds more. I did an entire day in 5 minutes. And I just picked a day at random. I didn't actually look at the size of the day or anything. I just said, okay, February 1st is a lovely day. I'll check that day. Currently, it dumps out everything. And part of the reason I'm bringing it here is because personally, I'm happy if it dumps out everything. That makes me happy because then I can, use other lovely Unix command tools, sort, awk, whatever, and give me a nice little summary. But that's me, and I'm the researcher. What would make it useful for other people is something I would really like to know so that I can improve it so that other people can use it. I've been told a graphic would be nice. Yeah, tell me what it should look like. People who used to work with me, who some of them are actually in the room, will tell you that, yeah, I don't do GUIs. In fact, they'll probably laugh at you and if you ask them if I do GUIs. Yeah, I don't do GUIs. And it is available on GitHub. It is out, it is open source, you can download it there. And any questions about BGPuma? Okay, well, I'll be around if you think of any way I can improve the output. Please, please let me know. So like I said, I'm very happy with, shell commands to parse the output, but I know most people are not, me.